Good morning and welcome to Sunday of week 2 of your Physics 5 a day. We're starting with a forces question here today, and in order to get the whole question on the screen, I've cut out the space. So there should have been a big space here for you to draw your diagram in, which is not there on the PDF, if you've got that. Okay, now you don't have to draw a scale diagram, they just say draw a vector triangle, but I have drawn a scale diagram because it makes something about the question really obvious. So there's my scale diagram, 2 centimetres to 1 kilonewton. Okay, and the angle, remember, you draw the first force, and then where that arrow finishes, you start the next one, and then the answer is from the start of the first arrow to the end of the last arrow. So the answer is there. Now, looking at the diagram, if I sort of extend that line out there, so you can see that this total angle here is 90 degrees, and so this one here is also 90 degrees. So the angle here between my two arrows is a right angle. Okay, and what that means is that this arrow is directly horizontal, which is really obvious when you've drawn a scale diagram. So it's along the direction of travel of the ship. Okay, and if I measure it and convert back, I get 2.6 kilonewtons there. So that is the total tension force from these two ropes, and it's in the forwards direction. Okay, and so then the question asks, state the value of the drag force acting on the ship. Well, if the ship is travelling this way, the drag force has to be in the exact opposite direction. And we are told that the ship is travelling at constant velocity, and that means that all the forces on the ship need to add up to 0. So if I just deal with the forwards backwards direction here, this is our total tension force that we've just worked out, and then the drag force must be the same size but backwards in order that there's no overall force, the total resultant force is 0.